We're recording. So, what we need to be able to do is find equivalent fractions. Now, this is something we've done before. So, can you remember why we want to? Why would we want to find equivalent fractions is a question. To simplify stuff, what do you mean by that?
So the fraction isn't as big.
Okay, yeah, I'll go along with that. So we could say, to simplify a fraction, like you've said, I think I'll put it in the to make the numbers easier is definitely one way, one reason to do it. Easier to work with. Yes, Sophie?
Maybe it's easier to recognize them.
What do you mean easier to recognize?
Like, for example, if it's, I don't know, 56 over 100, or 75 over 100, obviously if it's then 3/4, it will be maybe easier to recognize. I don't know.
Yeah, no, I think you're right. Easy to recognise. Like I think Jana said, it's easier to work with as well. Easy to recognise, easy to work with. Like you said, if it's 75 over 100 or 3 over 4, 3 over 4 is easier. Definitely easier to work with. Any other reasons that you can react on?
To turn them into decimals.
Oh yeah, okay.
No, but you could still do that with 75 over 100.
In fact, it's probably easier in 75.
Yeah.
But if you add 3 over 4, you might want to turn it into 75 over 100 to change. Yeah, no, that's good. I wasn't even thinking that. It's easier to turn into decimals. So for that one, for instance, 2/5 is not so easy as a decimal, but if we write that as 4/10 as a decimal, it will be
0. Yeah.
Yeah, 0.4. Good. Right, so yeah, easier to turn into decimals. And finally, for me, it's you cannot add or subtract fractions.
You can't?
With
different denominators.
There you go, exactly. Different denominators. So you have to be able to find fractions that are the same as what they were, but with the denominators the same for the two fractions you're trying to add together. Okay. So we've got now. I guess it's all three are good reasons to know how to do equivalent fractions. It's a tool. It's something you should know how to do. Right? What we're going to go to is, you can see those diagrams. We're going to have a look at the fact that equivalent fractions have to be the same size, and we need to think, well, how do we write equivalent fractions? So I think you've got it. Like the fact that you've already told me that 2/5 and 4/10 are the same thing means you know how to do it. But let's just visualize it a bit with these diagrams and check that you know they're actually the same. This would actually have been an ideal one to do with cake. Should have brought cake in for this one. Cut it up. But you brought your chocolate biscuits. Right, so if we have a look at these diagrams, right, what we're going to do, it says write in two different ways the fraction each shape has been shaded. Okay, so we're ready. So we've got these shapes, nice and simple shapes, and they have been split up. Okay, these rectangles. So what we've got to do is look at what fractions there are. So a fraction, can you explain what a fraction is? So we've got one number over another number. So we've got the numerator and the denominator. Can you explain what each number is? Start with the denominator, probably. So,
Well, the denominator shows you and tells you how many pieces are in total.
okay, good. So total pieces, and the top
And the
numerator.
top tells you how many are shaded in or how many are, I don't know, used.
Okay, I like that. How many used? Right. So in this case, it says there are two different ways that the only two, right? So obviously the most obvious split is that it's been split up into individual squares. So that would mean that the denominator would be
12.
12. Okay, so we've got something over 12. And then because we've split it into squares, how many have been shaded? Jana?
9.
9. So 9 out of 12 have been shaded. So that's one way. What is the second way of doing it then, Jana?
3 quarters.
3/4. So we have here, look, line like 1, 2, 3, 4. So we imagine that it's not, each one is not cut up. So we have got there also 3/4. Now, I've got a question for you. Can I think of it as this, split into thirds?
Yeah, no, because you could do that if it were 5 by 5 or 6 by 6, but obviously because the row and the column have different.
Well, I have thirds here. I have thirds. There are, 3/3. I've just shown you. But can I express the shaded region as so many thirds? Can you think of a reason why not? Why it's not going to work?
Well, first of all, I am a bit confused by just 3/4.
Oh, you don't know why it's 3/4?
Well, I know it's just my mind
Because
is blank.
look, we've got, if we treat it instead of individual squares, if I say each one of those parts, if I colour it in, yeah? I know they're all the same colour now, but so you've got split into 4 sections. So what you have to try and do is ignore these lines. So you've got 1, 2, 3, 4 parts.
Mm-hmm.
Rather than 12 little squares, you've got 1 part, 1/4, 2/4, 3/4,
Oh yeah, yeah.
4/4.
Okay.
And
Yeah,
how many are shaded? Well, 1,
yeah. 2,
2, 3 of them.
Okay.
So it's 3/4.
Okay.
Now that's the thing. So if I can do that,
Oh yeah, because 4 times 3 is 12, and so what you do to the top, you have to do to the bottom.
yeah,
So 3
yeah.
times 3 is 9.
So my question is, can I treat it in the same way? Can I say it's 1,
Yes. Yeah.
2? Okay, think about it carefully though.
Oh, I know why.
So if I say that, can I say how many thirds are shaded, Sophie? So if I
yeah.
treat it like that, so here's the shaded bit.
Yeah.
Really? What's the problem? If I deal with it in this direction, 1, 2, 3/3, what's the problem with the shading?
Oh, you only should be instead of 1.
Exactly. I haven't shaded in a whole third. Yeah? I haven't done it. So it doesn't work. You know, I can split 12 into 3 pieces,
Yeah.
but the shading doesn't cover the whole of one of those 3 pieces, only a part of it.
Mm-hmm.
So that means what I've got, 9 out of 12, 3 out of 4, will never be something over 3. This one can't happen because I can't rearrange the shading to fill up the block. Like I could try, for instance, to show if I do my shading, right? So these 3 are fine, but this one's empty. But what I'm going to do is I'm going to take this one this shaded region, and put it there. So that makes 1/3. And then this one I'm going to put here and make 1/3. Okay? So what that then gives me is how many thirds shaded?
2/3.
2/3. But the problem is this little bit is still left over. So I don't have how many thirds. I have 2/3 and... So that's a good, actually, that's an extension for us. I could say 3/4 is the same as 2/3 and 1...
1/4. 1/3.
No. What's 1 square worth?
Oh, 1/1.
1/12.
1/12, Jenna, well done.
Oh.
You see that? So we can't say how many thirds, but we've got 2/3 plus 1/12 left over. Yeah? Which should make sense because 2/3 is the same as how many twelfths?
4? No.
2/3, so 1/3 is 4, 2/3 is 2/3 is 8. So 2/3 is the same as 8/12. 8/12 plus 1/12 makes 9/12, which is what we have. Okay. But anyway, that's a bit of an extension to what we are supposed to be talking about. Right, so let's have a look at part B then. In the same way, how many squares in total?
12.
1, 2, 3, 4,
Oh, 10.
5, 10. And how many are shaded?
4.
4. And then if we look at it as complete columns, how many are shaded?
2.
Out of
5.
5. So we've got 2/5 or 4/10. Okay. Go on then, Jana. This one can be
6, 8.
6/8.
Ooh,
Or
or
Sophie?
three.
Or
Go on.
3/4.
3/4. Jana, this one?
9, 15.
9/15 or
3,
Yeah.
3/5.
Okay, now I understand it.
Great. Yeah. Now you were telling me a minute ago. How do I know that 9/12 and 3/4 are the same? Sophie, you mentioned something.
Yeah. Because they are equivalent fractions. Because 12 divided by 4 is 3.
Okay. So if we look at
Oh, sorry. Because 3 can go
9/12, 3/4 are the same
Yeah.
because
Because 9 of. Sorry, I don't know how to explain it.
I think you should go into. So 9 can be divided by
4.
3,
Sorry. And 12
and
can
so
be.
can.
Yeah.
So if I divide top and bottom by the same number,
Yeah,
I
it
get
gives
3
you-
over 4.
yeah, yeah.
And that's exactly how you find equivalent fractions. So if
Mm.
we have a look at this next set of questions, okay, fill in these. So what we have to do is we know they're the same, so we have to figure out what's been multiplied. So Sophie, this
12.
one. Well,
No,
so
I
what's
mean
it?
the
Yeah,
answer
no,
is
what's it been
12.
multiplied by?
4.
So that was multiplied by 4 to
And
get
so
the
you
top.
have to do the
So
top as
have
well.
to do the top.
And so 4 times 3 is 12.
Make sense?
Yeah.
Go for it. Okay, so Jana, 3/4 is
You times by
times by 3, so it becomes
9.
9 times. Just change.
Oh. What? Are we doing A?
We did A.
Oh, yeah. Yeah, times 3.
Okay. Sophie, see?
And you times it by 5.
Times
so
by
5
5.
times 7 is 35.
Yeah.
And 5 times 4 is 22.
Yeah. Okay, Jana, D?
You times by 2.
Times by 2,
So
it's
it's
10 over 8. Yeah. So, Sophie?
You times by 4, so 4 times 3 is 12.
Yeah. Take it in turns. So Jana next,
10.
F.
Times by 5. So it's
Yeah, good.
Times by 6, so it's 24.
Yeah,
15. Times by 4. So it's 8.
yeah,
Times by 6, so it's 54.
yeah,
Times by 4. So it's 16.
yeah,
Times by 6, it's 42.
yeah,
Times by 8. So it's 40.
Good stuff.
Mhm.
Easy.
Yeah.
So, next time, we know how to do fractions in simplest form.
Can I?
Should we do it very quickly
Yes,
before we
please.
have to go then? Take it in turns then. Go on then, Sophie.
2/4, so 1/2.
1/2. Jonah?
3.
No, can't be. Have to divide by 3 maybe. So it's
2.
2/3, 2/3. Sophie?
10. So you divide by 5.
Divide by 5,
Yeah.
yeah. So it's over
So it's
5.
4.
4/5. Okay. Last one, Jonah. It's got to be divided by 3.
Yeah.
So it's 1/6.
Yay.
Cool. Congratulations. Have a good day.
Thank you. You too.